Hey everybody, it's Jenny from Norman S. Wright. So there's a lot going on with refrigerants lately around code changes, upcoming phase outs, and new refrigerants coming on the market. So I thought it'd be good to talk about refrigerants. It is such an important part of the HVAC industry. So before I get into all the details that I just mentioned, let's do some refrigeration basics. So let's get started. ASHRAE Standard 34, Designation and Safety Classification of Refrigerants, establishes a simple means of referring to common refrigerants rather than using their chemical name formula or trade names. ASHRAE assigns number and safety classifications to the refrigerants based on toxicity and flammability data submitted by the refrigerant manufacturer. You'll see refrigerants labeled with an R number, like R12, R22, R32, and R114. So what do those numbers mean? So if you look at R, and let's call it XYZ, the R designates it as a refrigerant. Let's look at what the other numbers mean. If X is 0, it's a methane series refrigerant. But the 0 is not written, so you'll see R12 and R32 as methane series refrigerants instead of R012 or R032. X equals 1 means it's an ethane series. 2 means propane. 4 is a zerotropic mixture, which means that the mixtures have different boiling points. 5 is an azeotropic mixture, meaning that the mixtures have the same boiling point. 6 means the composition is organic. 7 means the composition is inorganic. Make a little bit more room. 11 stands for unsaturated ethane compounds, and 12 stands for unsaturated propane compounds. For the Y and Z numbers, it's different depending on the X number. So for X equals 0, 1, 2, 11, and 12, Y is the number of hydrogen atoms plus 1, and Z is the number of fluorine atoms. So R22 is in the methane series and had 1 hydrogen atom and 2 fluorine atoms, and R32 is in the methane series and has 2 hydrogen atoms and 2 fluorine atoms. So for X equals 4 or 5, Y and Z are ordinal numbers, so basically it's just defining the sequence. It goes from R400 to R454 right now, and from R500 to R513. For X equals 6, Y and Z describe subgroups, and for X equals 7, Y and Z are molar mass. Let's make a little bit more room. So then there are also sometimes letters at the end. Lowercase letters describe the structure of the molecule. For example, R600 is butane and R600A is isobutane. These compounds have the same chemical formula, but their arrangements are different, and therefore they have slightly different properties. Let's move it up a little again. Capital letters describe specific mixing proportions of different components. For example, R407 has A through E in capitals. And there are different mixtures of refrigerants, R32, R125, and R134A, but each letter designates a different ratio. Let's move all this aside so we can talk about safety classifications. ASHRAE 34 also assigns an identifying reference letter and number to each refrigerant to classify it according to the hazard involved in its use. The capital letter designates a toxicity class based on allowable exposure, and the number denotes flammability. The table looks like this. A is lower toxicity and B is higher. Then there are 3 numbers for flammability. 1 for refrigerants that do not propagate a flame when tested in the standard, Class 2 for refrigerants of lower flammability, and Class 3 for highly flammable refrigerants such as hydrocarbons. ASHRAE recently updated the safety classification matrix to include a new flammability subclass 2L for flammability class 2 refrigerants that burn slowly. Some refrigerants that have very low global warming potential are mildly flammable and are classified as A2L. This indicates that they are lower toxicity and have low burning velocity. Okay, so let's move this out of the way so we can talk about global warming potential. Many refrigerants are potent greenhouse gases. Refrigerants are classified by their global warming potential, GWP. a metric that compares the total contribution of a given mass of the refrigerant gas to the equivalent mass of CO2. Many common refrigerants have GWPs in the range of 1,500 to 2,000. R22, for example, has a GWP of 1,800, meaning that 1 pound of R22 in the atmosphere is equivalent to almost 1 ton of CO2. While refrigerant systems are not intentionally vented to atmosphere, since refrigeration systems frequently require changes of hundreds of pounds of refrigerants, a leaky refrigerant system can have an immense effect on global warming. Selection of refrigerants and their systems must be based on a complete analysis, including their performance and energy efficiency, but also environmental impacts, employee and public safety, and economic considerations. We'll go into the issues, concerns, phase-outs, and more in future videos. But for now, that's the basics of refrigerants, numbers, classifications, and GWP. Don't forget to subscribe to our YouTube channel, and thanks for watching.